Okay, now that you have been introduced to other statistics, you know, to have a recap on what we've done in the other material, when you have random variable that are independent, that have not been ordered, that have a PDF and a CDF, we, after ordering them from the smallest to the largest, we can also derive the probability distribution of them. Okay, that is what I introduce into. Okay, and of course I derive the how to get the probability distribution of the minimum, the probability distribution of the maximum, and I also derive how you can actually figure out the probability distribution of ordered SJ that lie between the minimum and the maximum. And not only that, I also walk you through the probability distribution of the joint of two ordered variables. Okay, and not only that, I also walk you through the probability distribution of the joint of random variables. So we're going to continue learning other statistics from this material, and of course I've already introduced you to other statistics. You know, when you have set of variables that have not been ordered, and they have their probability distribution, they have a CDF, they got a PDF, and of course, after ordering them, you're seeking to determine the probability distribution of them. Okay, using the information of about the PDF and the CDF of the unordered variable. Okay, so I think we're gonna have a lot of examples in this material. Okay, now, if we let x1 to be this and x2 to be this and x3 to be that and x4 equal to that and x5 equal to that, you're gonna. So what did you notice? So what you notice here is that they've not been ordered, right? They've not been ordered. Okay. So this has not yet been ordered. Okay. And you know what? After ordering them, this is what we're gonna have. Okay, after ordering them. Okay, you are from the smallest, okay, to the largest. Look at that. So this arrangement here is different from this arrangement. Okay, so this x1 up to x5 have not been ordered, and after they are ordered, this is actually what we have. And you know what, after they are ordered, that will give you opportunity to determine. You can determine the median, you can determine the range, right? Okay, after finding a median from a set of observation, we require ordering them from the smallest to the largest. And of course, my median here is actually y3, which is 0.62. And you know what? We can also find the range, right? Which is going to be the difference between the smallest and the largest. Okay, so take a look at that example. And of course, in my last lecture, I told you I walk you through the probability distribution of the joint of ordered random variables, okay, which is n factorial, multiplied by their respective map probability, okay, distribution. So in a short form, if I want to rewrite this guy here, I'm actually gonna write it like that, okay? So you got that's a product, okay? So that is the same as that. So take a look at that. Okay, now I think I walk you through an example of uniform, uniform the other time. Okay, where f of x equal to 1, where the range actually lie between 0 and 1. Now, what if you are asked to find the joint PDF, okay, of the other statistics for the uniform distribution, and after that, the standard exponent for you can do that for the standard exponential and for the normal as well. Now, if you want to start that of the for uniform, of course, f of s equal to 1, right? And the probability distribution of the joint of the ordered variable, or this supposed to be y2, okay? So it should be y1, y2 up to yn, which is going to be, you remember the formula, n factorial, okay, they multiply by f of y1, f of y2 up to f of yn. So what I'm trying to tell you right now is that if f of s equal to 1, okay, now what does that mean is that the formula that we're actually using here for y1, y2 up to yn, okay, is actually n factorial f of y1, okay, multiply by f of y2, okay, until you get to f of yn. And of course, if f of x equal to 1, then automatically f of y1 will be equal to 1, f of y2 will be equal to 1, and so on. So this guy is going to be 1, okay, this is going to be 1, all of them are going to be 1. When you time, you multiply 1 by 1, of course, by n factorial, then you're actually going to have n factorial. So that was why I got n factorial right here. Okay, like I said, this guy here is supposed to be y2. Okay, so take a look at that. So that is for the uniform. Okay, now if you want to solve that for exponential, like you are giving the parent distribution f of x of an ordered, the PDF of an ordered variable to be exponential, and then you actually want to find the PDF of the joint. Okay, using the formula again, the formula is actually gy1 gy2 dot 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 until you get to gyn. It is going to be n factorial, then f of y1, okay, multiplied by f of y2, blah blah blah, until you get to f of yn. Okay, so what you're going to do here, you're going to write n factorial. What is going to be f of y1? Now this is what I wanted to take note. So if f of x equal to that, then f of yi, okay, is actually going to be equal to exponential raised to the power minus yi. Okay, for I start from 1 to n, they're actually going to be identical. Okay, because of that, so for f of y1, what I'm actually going to get is going to be exponential raised to the power minus y1. For f of y2 is going to be exponential raised to the power minus y2. Okay, give me 1 second. Let me rewrite that. Let me rewrite that. Okay, now f factorial. So like I said, for f of y1, I'm actually going to have exponential raised power minus y1. The f of y2, I'm going to have exponential raised power minus y2. Okay, until I get to exponential raised power minus yn. Okay, and you know what? If I want to rewrite this, okay, in a short form, okay, what am I going to write? Okay, I'm actually going to write, going to be n factorial exponential, okay, minus into y1 plus y2, okay, blah blah blah, okay, until I get a yn. Okay, if I now want to write that in short form, okay, if I want to write that in short form, automatically writing that in short form, okay, it's going to be summation yi. Look at that. That's all you have at that, right? So take a look at that. So therefore, what I'm trying to say now, the joint, the probability distribution of the joint of the ordered is actually going to be equal to this. Okay, like I said, don't forget. So this guy here is going to be y2. Okay, is actually, that's a mistake. It's supposed to be y2. Okay, now how do we find the that for the normal standard normal distribution? The f of x, when x follow a standard normal distribution, we have the PDF given as this. This has not been ordered, right? It has not been ordered, and if I want to get the probability distribution of the joint of ordered, okay, so what formula am I using? Okay, so it's gonna be gy1 comma gy2 blah 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 until you get to gyn is gonna be n factorial, okay, f of y1, okay, multiplied by f of y2 dot 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 f of yn. Okay, and you know what, the f of y, if since the f of s is actually be equal to that, then it means f of yi, okay, will also be equal to 1 over square root of 2 pi, okay, exponential raised to the power minus yi squared, uh, yi squared divided by 2, okay, and and that is the reason it means for I, and this is going to range for I start from 1 up to n. So that for f of yi, okay, so what I'm trying to talk about now is that For f of y1, okay, it's actually going to be 1 over square root of 2 pi, okay, exponential raised to power y1 squared divided by 2. Okay, for f of y2, okay, it's also going to be the same, except that you're going to plug in y2. Okay, so when you do that, and then if you now use the g of y1, y2, okay, up to yn, okay, after writing the n factorial, okay, and you have 1 over square root of 2 pi. Okay, those exponential, don't forget you're actually going to have minus into, after combining that, you're going to have y1 squared divided by 2 plus y2 squared divided by 2 until you get to yn squared divided by 2. And of course, you can write that in short form. So writing this guy in short form is actually going to be that. So what I'm trying to tell you now, the whole of that now become the probability distribution of the joint of the ordered random variable, okay, of a standard normal distribution. Okay, now, you remember the other time I talked about gate order. Okay, when I talk about gate order, is actually the the SJ we actually lies between the minimum and the maximum, right? Okay, so it's the same thing as I can say gate order, I can say out order. Okay, in the other material that that I just walk you through, I call that gate order, but here I'm calling it out order. It's actually the same. Okay, so this is actually the probability distribution of an ordered YR that lie between the minimum and the maximum. Okay, so take a look at that. And of course, if this is what is it called? If this is a PDF, then automatically, and let me tell you this, it is extended, it is the whole of this. So this, okay, all of this multiplied by this, okay? So that is what I mean. And of course, the y outline between negative infinity and positive infinity. And of course, in the last material, I also walk you through the probability distribution of the largest order. I derived that for you, right? Okay, so this is the probability distribution of the largest order, and this is the probability distribution of the smallest order statistic. Okay, now I want to walk you through an example now, okay, where you have a y1, okay, less than y2 less up to y6. It means this is already ordered. Okay, this have been ordered already. Okay, because the smallest here is going to be y1 and the y6 is going to be the largest, right? How many variable do we have altogether? It means your n equal to 6. Okay, now if you are given the PDF of unordered to be f of s to be 1 over 2, okay, where x lie between 0 and 2, and you know what, a question can be asked, you can be asked to find the probability distribution of YR. What is YR? Of course, the YR in this case could be whatever, could be any of this. Okay, take a look at that. But then you can also be asked to find the probability distribution of the maximum, of the minimum, and the probability distribution of the maximum. But let me tell you this: if you want to figure out g of yr, of course, you're actually going to make use of the formula right here. Look at that, the whole of that. Okay, you're going to make use of this formula right here. And don't forget, you need to identify your n. Okay, your n equal to 6. Because I got 6 variable, you're going to plug in 6. Okay, I'm going to show you. You're going to plug in 6 for n. Anywhere you see n, you're actually going to plug in 6. Okay, and when you plug in 6, okay, this is what you're going to have. Okay, this is what this formula right here. Okay, the whole of this formula right here. Okay, when you plug in 6, okay, for n, okay, we are plugging in 6 for n because we have 6 variables. Okay, when you plug in 6, this is what you're actually going to have. And you know what? This is the density function of yr. Okay, it's going to be in terms of yr. Now, if you now want to get g of y1, well, you know what you're going to do? To get g of y1, which is the distribution of the smallest, oh my God, you just need to plug in r to be 1. Okay, if you plug in r to be 1, okay, that is going to give you, you're going to have this. Look at that. So which means from here, if you plug in your R to be 1, okay, automatically this is what you're going to have, okay. And you know what, the y1 lie between 0 and 2. Now if you want to find the that of the maximum for 6, you just need to plug in 6 for R, okay, and you simplify. Okay, when you do that, you're going to have this. So you're done. Oh my god, so easy. And let me tell you this, you can be asked to find the expected value, okay. You can be asked a lot of questions. You can be asked to find the expected value of yr, okay. If you want to find the expected value of yr, you're going to be integral yr, okay, the g of yr, okay, the yr, okay, and you're going to do from 0 to 2, okay. Based on this, you can be asked to find the mean, okay. But this is the distribution of, you know, out order, okay. Take a look at that. So similarly, for the smallest, you can also be find like using this now. You can be asked to find the expected value of y1, which is going to be integral y1, okay, g of y1, the y1, right? And what is the range of y1 from 0 to 2? You can be asked to find the mean of that. You can find the variance as well. You can also be asked to find the expected value of y6, okay, which is going to be y6 g, okay, of y6, the y6, and look at the range from 0 to 2. You can be asked to find the mean, you can be asked to find the variance, and so on like that, because they represent the probability distribution of the smallest. There's a lot of smallest, there's a lot of, smallest become a random variable, and largest also becomes a random variable. You can find the average, okay? So take a look at that. I think I gave another example now. I'm going to go into another example now. Let x1, x2, x3, x4, x5. So they are on order, right? It's a random variable from beta population with parameter beta equal to 1 and alpha equal to 2. Okay. And after 100, then this is what you have. Okay. And you let the other statistics of the sum. The f of x is given to be 2x. How do I know it's 2x? I'm going to tell you now. You are told if you look at a beta distribution, the beta distribution, you have x raised to power alpha minus 1, 1 minus s raised to power beta minus 1. Then we have gamma alpha plus beta divided by gamma alpha, gamma beta. If you plug in, beta to be 1 and alpha to be 2, okay, now take a look at that. So where beta equal to 1 and alpha equal to 2, I'm actually gonna have f of x equal x, okay, alpha minus 1, so 2 minus 1, okay, you can see that. Okay, then I'm going to have 1 minus x raised to power b minus 1, which is 1 minus 1. Then gamma, alpha plus beta is going to be 1 plus 2, right? Then gamma 1, gamma 2, right? Okay, so what is the f of s going to be? So it's actually going to be x, okay, and 1 minus x raised to power 0, that is going to be 1. And what is gamma 3? Gamma 3 here is going to be 2 factorial, which is going to be 2. And gamma 1 is 0 factorial is 1, gamma 2 is 1 factorial is 1. And that was why we have f of x to be equal to 2x. Okay, can you see that now? That is how you get f of x to be equal to 2x. Now, f of x equal to 2x, now they wanted to find the probability distribution of the maximum, the probability distribution of the minimum, and they also wanted to find the probability that y would be less or equal to 0.2. They also wanted to find the probability distribution of the ordered y3. Then they wanted to find the variance. So you can do that. Okay, you can actually do that. Okay, this is showing what I was showing before about the expression for beta distribution. Okay, so take a look at that. Okay, so and the f of s have been derived to be that, and if the f of s equal to 2s, of course you can get the CDF. So these are for the unordered, because before you can actually find the distribution of the maximum, of the minimum, and other stuff, you need to first know the probability distribution of an ordered variable and the CDF of another variable. So this is the CDF of the unordered variable. Then, so based on this and this now, of course, you can use, going by the formula that we have before, and you can actually find this, you can find that. Okay, I'm giving you that as an exercise right now. You make use of what we did before. You can, you remember for this now, you are actually going to use, going to be n into f of x, okay, raised to power n minus 1, okay, f of x. That is the formula you're going to use, okay, if you want to figure that out. Okay, your n is going to be 5. Okay, you're going to put 5 here, and your f of x, the CDF has been determined to be s squared. Okay, you're going to put it here, and 5 minus 1, then your f of x is actually 2s. Then all what you just need to do is to simplify, then you are done. Okay, now I also walk you through, I also show you the probability distribution of the joint. Okay, I think I show you the other time. So this is the probability distribution of the joint, yi and yj, that have already been ordered. Okay, and of course, based on you know, on this question, you can also find the probability distribution of the joint of y2, y4. Or what you just need to do is to plug in what is your n, what is your I, and what is your j. Okay, your n will be the number of the question of the variable. The n is equal to 5. Okay, and I here, this actually implies I equal to 2 and j equal to 4. Okay, don't forget, you want to find the probability of joint of yi and yj. Okay, I is going to be 2 and j is going to be 4. Then you're going to plug in that uh into what we have right here. Okay, so you'll be able to come out with the probability, joint probability distribution of the joint. Okay, so I'm going to walk you through that on Monday. Okay, so you know you just plug in that, like just like what I said. Okay, now um you are given another question now, and you have f of s to be equal to exponential raised power minus x, and they ask you to prove that the two other statistics, okay, the z2 and the z1, okay, are independent. Okay, the z2 and the z1 are independent, and you know what, the z2 is actually the difference between the y4 and the y2, and the z1 is actually equal to y2. I want to tell you, if you really want to show that a z2 and z1 are independent, you needed to for derive the joint probability distribution of, oh, give me 1 second. You need to for derive the joint probability distribution of z2. You have to show that the joint probability distribution of z2 and z1 can be written as a product. Okay, now you can actually use the method that I use on Monday and Tuesday, the method of transformation. Okay, where you need to first obtain, if you want to start, you need to first obtain um, what is f of x1, the f of x1 s2. Oh, yeah, so what is f of x, what is the join, okay, of this one, okay, which is actually going to be, you need to find f of y2 and y4. Okay, the f of, you need to first figure out the f of y2, f of y4, and after getting the f of y2 and the f of y4, then you need to use the gz2 and the z1 is actually going to be a function where you are experiencing, you are y2 in terms of z1 and z2, and and y4 in terms of z1 and z2, okay, or multiplied by determinant of Jacobian. Okay, I'm actually going to walk you through that on Monday. Okay, I deliberately left this question now. I'm going to walk you through this on Monday. Okay, now let me see, did I want to solve it? Let me see, where am I solving it? Oh, okay, I think I'm solving it. Okay, so like I said, I told you you're going to get your f of s is already this guy here, and you need to get a CDF for that, right? Now the CDF is actually this. Okay, the CDF of this is actually this guy here. Okay, and some of you may be wondering, how are you going to get the CDF? Is the probability of a biggest less or equal to that, which is going to be from 0 to x, is 0 to x f of t dt. Okay, so uh, you have a 0 to x exponential raised to power minus t dt. So when you do that and you plug that in, you're going to get your CDF. And the moment you get your CDF, then you can go back and use the formula of the joint here. Okay, you go back and use the formula of the joint. Okay, now the joint, the formula, your I is going to be 2, your J is going to be 4, and of course your N is actually going to be 5. Okay, so when you plug that in here, okay, you're going to be surprised. What you actually going to get is going to be this guy here. So this is the distribution. This is GY2 and GY4. And you know what? The moment you have this guy now, you can now use the Jaco. You can now, don't forget what you are seeking to get. You want to answer a question on whether Z2, whether Z1 and Z2 are independent. Okay. From here, you need to also derive the probability of Z1 and Z2. And of course, if you want to do that, okay, based on what you have here right now, okay, you actually need to express y2 as a function of z1 z2, okay, y4 as a function of z1 z2, then all multiplied by determinant of Jacobian. And of course, if you take a look at what I have here, okay, if z1 equal to that, of course you can actually have y2 to be z1, okay, and y4, okay, from here, y4 to be equal to z2 plus z1. Look at that. So which means your Jacobian is going to be based on that. It's going to be 2 by 2, where you can find the y2, the z1, okay, the y2, the z2, okay, and then you can also find the y4, the z1, okay, then the y4, the z2, okay. So whatever you get here is going to be your Jacobian. And so then you're actually going to go into the function here, where you're going to substitute for y2 in terms of z1 and z2, substitute for y4 in terms of z1 and z2, then you multiply the whole thing by Jacobian that you got, and automatically that will take you to G1 and GZ1 and GZ2. Now, when you have the GZ1 and GZ2, you can now find the GZ1, okay, which is marginal, so which is going to be the integral of the joint, right? Okay, you're gonna find the integral of the joint, okay, with respect to that, and you're gonna do the same thing for this guy here, which is integral g of z1 z2 dz1, okay. This one is dz2, okay, and at the end of the day, what you get, if the product of this multiplied by this actually give you the joint, then you've already showed that z1 and z2 are independent. Okay, so I'm actually going to walk you through that in class on Monday. Okay, so you have another question that said, okay, you have this guy that are already been ordered and n equal to 5, and therefore first equal to 2s, which s lie between 0 and 1. You want to find the probability of y4 less or equal to half. Before you can find the probability of y4 less or equal to half, you need to first find the distribution of y4, okay. You need to first find the distribution of y4. So what I'm trying to say, you need to first find the g of y4, okay. You need to first find the g of y4. And you know what, if you want to find the g of y4, you need to make use of the distribution of the rth order. I'm going to show you. You're going to make use of the distribution of the rth order, okay. You're going to make use of this guy here. Give me one. Yeah, you're going to make use of this guy here, okay. You're going to, so all what you're just going to do, your r, okay, your r will actually be equal to 4, okay. You're going to plug in r equal to 4 and your n equal to 5 based on the data set. Give me one. Yeah, your n equal to 5 and your r equal to 4. So when you plug in n equal to 5 and r, equal to, give me 1 second. I think I'm gonna work out this for you. Let me snap the distribution of the out other statistics that we actually want to use. Give me 1 second. I'm gonna snap that, and I'm actually gonna make use of my whiteboard. Okay, I'm gonna make use of my whiteboard. Okay, give me 1 second. Okay, I think I just snapped that now. Because I want to answer this particular question here. Let me also snap that. Okay, now, okay, yeah, to answer that particular question there, okay, like I said, you want to find the probability of y4 less or less than half. And I said the very first thing you need to do, you need to first find the joint of, you need to get the probability distribution for y4 before you can find that probability. And what I'm trying to tell you now, if you want to find the probability distribution of y4, okay, if you want to find the probability the distribution of y4, you're actually going to make use of the probability distribution of yr. Okay, and of course, the probability distribution of yr in terms of the formula is n factorial divided by r minus 1 factorial n minus r factorial f of yr. Okay, and a CDF of yr, okay, raised to power r minus 1, okay, and 1 minus CDF yr, okay, raised to power n minus 1. Okay, take a look at that. Now, what I'm going to do now, I'm actually going to plug in r to be equal to 4, and I'm going to plug in n to be equal to 5. Okay, so when I plug in r to be equal to 4, then you're going to see that there were anything r. So this is going to be this is going to be uh, is going to be 4. Okay, and this is going to be 4 right here. Give me 1 second. So this is gonna be 4. Okay, this is gonna be 4, and up there, that is gonna be 3, right? 4 minus 1, that's going to be 3, and this is going to be 4, and n minus 1, n equal to 5, of course, that is going to be 4, right? That's going to be 4, right? Okay, and the n factorial, n equal to 5, so this is going to be 5 factorial, and 4 minus 1 factorial. So so when you do that, you're actually going to have this in terms of f of y4, and it's an uppercase f of y4 as well. Now, if so, this is going to be 5 factorial, that's going to be 120, and 4 minus 1, this is going to be 3 factorial, and 5 minus, that's going to be 1 factorial. So I'm actually going to have 5 factorial, that's going to be 120, and 120 divided by 120 divided by 3, does that look like 40, right? Let me see. Let me see. Okay. This is 120, right? This is 3 factorial. Oh, 3 factorial is 6. Okay, if 3 factorial is 6, 6 goes in 120. So 120 divided by 6, that's going to be 20. Okay, so my G of Y4 is actually going to be 20. Okay, then I'm going to have F of Y4. Okay, uh, give me 1 second. I'm going to have f of y4, okay, and a capital this f of y4, okay, raised to power 3, okay, then 1 minus f of y4, okay, raised to power 4, okay. That is what I'm going to have at the moment, okay. Now, let me now write it out. I'm going to write it out, okay. I'm actually going to write the how. Okay, so my G, okay, of y4 is actually going to be 20. Okay, f of y4, okay, the capital F, okay, of that raised to power 3, and then 1 minus this raised to power 4. No, that's what I have. That is the distribution now. But you know what? You've been given that f of x equal to 2x. Okay. And if f of x equal to 2x, don't forget your capital F of x is actually going to be s squared. Okay. And you know what? If f of x equal to 2x, then f of y, small f of y4 is going to be 2y4. Okay. And big f of y4 is going to be y4 squared. Okay, using this guy here. Okay, so if I want to rewrite this now, I'm actually going to have 20. Okay, what is f of y4? The f of y4 is 2y4. Okay, then into what is the CDF? So that's going to be y4 squared raised to power 3. Then I'm going to have 1 minus y4 squared or raised to power 4. Now take a look at that now. So if you simplify, we're going to be 40, okay, y4, okay, and if you simplify this guy here, you're actually going to have y4 raised to power 6, right? And then 1 minus y4 squared raised to power 4. Okay, now because I need room right now, because I need room, I'm cleaning this guy now. I'm cleaning that now. Okay, I'm cleaning that one, and obviously, my GY4 will actually be equal to 40. Okay, Y4 raised to power 7, then 1 minus Y4 uh, y4 raised to power 2 raised to power 4. Okay, that is what I have now. And I'm going to write my y4 lies between 0 and 1. Now, now that I've gotten my PDF now, then it is time to find out. Okay, it is time to find out. Okay, now if I want to find, oh my God, let me see if I can actually I want to have that back. Oh, okay. So I'm getting that back. If I now I want to find that one now. If I clean this guy here, okay. Now finally, I want to find the probability of y4. Okay, you can actually check if this is correct by seeing whether it's going to integrate to 1. Okay, you can actually check before you actually use that to find the probability of y4 less than half. Now what I'm going to say now the probability of y4 less than half will be equal to is 0 to half. Okay, okay, 0 to half, then 40, okay, y4 raised to power 7, 1 minus y4 squared, okay, the y4, okay. So whatever I got there is actually going to be my result. Okay, you can solve that out. Okay, so this is going to be the end of my lecture, and in case you need clarification, you can actually meet with me. uh, but you know what? On Monday, I'm actually going to walk us through some practice questions. So that is going to be the end of our lecture for this semester. I'm going to, like I said, I'm going to hold my office